Hello everyone. The topic for today's class is switching. As we all know that this paper is about data communications and networking. So we will study about how different devices are connected to form communication networks. First of all, let's see what a network is. A network is a set of connected devices. When there are multiple devices, there exists a problem of how to connect them to make one-to-one communication possible. It can be done by various methods like uh, a mesh topology, that is to make a point-to-point connection between each pair of devices, or through a star topology where the central device and every other devices are connected. These methods, however, are impractical and wasteful when they are applied to large networks. So a better solution is switching. What is switching? Switching or a switch network is a network which consists of a series of interlinked nodes called switches. And these switches are devices that are capable of creating temporary connections between two or more devices linked to the switch. This is an example of a switch network. Here the end systems or the communicating devices are labeled as A, B, C, D, and so on. And the switches are labeled as 1, 2, 3, 4, and 5. And we can see that each switch is connected to multiple links. We have three methods of switching. The first is circuit switching, then the packet switching, and message switching. The first two switching networks, that is circuit switching and packet switching, are more commonly used today. And the packet switching can further be divided into two subcategories, that is virtual circuit approach and datagram approach. Here, let's see which method of switching occurs in which layer of the TCP/IP model. Switching is implemented at the physical layer, data link layer, the network layer, and even logically at the application layer. And the circuit switching takes place in physical layer. Datagram network, which is a form of a packet switch network, takes place in the network layer. And another subcategory of packet switch network, that is a virtual circuit network, takes place in the data link layer. And the message switching takes place at the application layer. The circuit switch network. A circuit switch network is a type of network that consists of a set of switches connected by physical links. In these circuit switch networks, the connection between two stations is a dedicated path which is made of one or more links. And its connection uses only one dedicated channel on its link. And its link is normally divided into n number of channels by using the FDM, that is frequency division multiplexing, or time division multiplexing, TDM. We have three phases of circuit switching. The first is the setup phase, the second is the data transfer phase, and the third one is the teardown phase. First, the setup phase. Before any two parties or before any two end systems, here the end systems are A and M. So taking this example, before these two end systems can communicate, a dedicated circuit, which is a combination of channels in links, needs to be firstly established. So the end systems are normally connected through the dedicated lines to the switches. So that connection setup means creating dedicated channels between the switches. Here, when this end system A needs to connect to the end system M, it will send a setup request that includes the address of system M to switch 1. And the switch 1 finds a channel between itself and the switch 4 that can be dedicated for this purpose. And after that, the switch 1 then sends the request to switch 4, which finds a dedicated channel between itself and switch 3 again. And the switch 3 will inform system M of system A's intention. And in the next step to making a connection, an acknowledgement from system M needs to be sent to the opposite direction to system A. And only after this, then the connection will be established. And also an end-to-end addressing is also required for connecting a connection between the two end systems. That is about the first phase, that is the setup phase. And the next one, data transfer phase. After the establishment of the dedicated circuit in the setup phase, then the two end systems can finally transfer their data. And after this, when one of the parties or when one of the end systems needs to disconnect, then a signal is sent to its switch to release the resources, which is also called the teardown phase. Circuit switch networks are not as efficient as the other types of networks, such as the packet switching and the message switching, because here, as we have seen earlier, the resources are allocated during the entire duration of the connection. So these resources are unavailable to other connections. Therefore, the efficiency is low compared to the other two networks. However, in a circuit switch network, the delay is low because in this type of network, during data transfer, the data are not delayed at its switch because the resources are allocated for the duration of the connection. So even though the efficiency is low, the delay in circuit switching is minimal. Coming to the second type of switching, that is the packet switching. In data communications, messages are sent from one end to another. So if the message is going to pass through a packet switch networks, it needs to be divided into packets. And these packets can be of a fixed or of a variable size. And the size of the packet is determined by the network and the governing protocol. Unlike the circuit switching, In packet switching, there is no resources allocation for a packet, which means that there is no reserve bandwidth on the links, and there is no scheduled processing time for each packet. In other words, we can say that the resources are allocated on demand. Here, when a switch receives a packet, no matter what the source or destination is, the packet must wait if there are other packets being processed. And there are two types of packet switch networks. Those are datagram networks and virtual circuit networks. First, let's see datagram networks. In a datagram network, each packet is treated independently of all others. So even if a packet is a part of a multi-packet transmission, the network will treat it as though it existed alone. And the packets in this approach are referred to as just datagrams. This is an example of a datagram network. In this example, as we can see, there are uh, four, um, four packets or four datagrams that belong to the same message. And these packets, even though they belong to the same message, may travel different paths to reach their destination. These datagram networks are sometimes referred to as connectionless networks also. Why they are called this connectionless network is because here the switch or the packet switch does not keep information about the connection state. And unlike the circuit switching, there are no setup or teardown phases. And each packet is treated the same by a switch regardless of its source or destination. But this type of datagram networks, they have this routing table. So in this type of network, each switch has a routing table that is based on the destination address. So the routing tables, they are dynamic and they can be updated periodically. And the destination addresses and the corresponding forwarding output ports are also recorded in the routing table. This is an example of a routing table. Coming to the destination address, every packet in a datagram network carries a header that contains, among other information, the destination address of the packet. So when the switch receives the packet, the destination address is examined and the routing table will be consulted to find the corresponding port through which the packet should be forwarded. Efficiency. The efficiency of datagram network is better than that of a circuit switch network because in datagram networks, the resources are allocated only when there are packets to be transferred. And if a source sends a packet and there is a delay of a few minutes before another packet can be sent, then the resources can be reallocated during these minutes for some other packets from other sources. In case of delay in datagram network can be greater than the circuit network. Because what happens here is that although there are no setup and teardown phases, each packet may experience a wait at the switch before it is forwarded. Next, we have the virtual circuit networks. A virtual circuit network, as the name suggests, is a cross between the circuit switch network and a datagram network. So this means that the virtual circuit network has some characteristics of both circuit switch network and also the packet switch network or the datagram network. As in the circuit switch network, even virtual circuit networks have the setup and teardown phases in addition to the data transfer phase. So um, this particular characteristic, it shares with the characteristic of the circuit switch network. And in case of virtual circuit networks, the resources can be allocated during the setup phase, just like in the circuit switch network, or on demand as in a datagram network. So this particular characteristic is similar to both the circuit switch network as well as the datagram network. And as in the datagram network, data in virtual circuit networks are also packetized, and each packet carries an address in the header. And just like in a circuit switch network, all packets in a virtual circuit network follows the same path established during the connection. A virtual circuit network is normally implemented in the data link layer, while the other types of networks, such as the circuit switch network, is implemented in the physical layer, and the datagram network is in the network layer.